This illustration deals with general outdoor transformers. And in the previous illustration, we talked about 250.24A2, said you had to ground the transformer outside. Then 250.24A1 and through those sections of A deal with grounding at the service. So we ground the transformer, we ground at the service equipment. And we could even put a supplementary ground at the meter if the utility would allow us to ground in the meter. But the main thing, we're talking about grounding on the line side where there's not an overcurrent device ahead of your conductors. Now notice, if you wanted to review our UL standard 467, then we would review section 6-1 through 6-6, and we have parallel requirements there that you can find more about the pros and cons of grounding the transformer and the service equipment. Now next, let's look at the grounding loop. 220.61A deals with the neutral has to be sized to carry the unbalanced load. So I'm just giving an example. If we had 150 amps on the neutral, L1, 120 on L2, and 130 on L3, then the neutral would have to carry 150 amps. That would be 220.61A. 310.15E1 through E3 deals with how you use the neutral in the electrical system. Now E3 to 310.15 is important. And as an example, it's the major portion rule, which is 50%. Now you can find this as 50% in 400.5A as an apple of the NEC. But as an example, and most all inspectors go along with this concept. If you had 100 amps on L1 neutral load, L2 100 amps, and L3 100 amps, all neutral load, and 51 amps or more of that load was harmonic nonlinear loads, then the neutral would be considered current carrying in the electrical system under certain conditions. See? Now, if we look at 220.61C2 and read the informational note 2, it again deals with that neutral conductor. And the golden rule for sizing and determining ampacity of conductors is 310.14A3, and that would be atoms 1 through 4. Very important that we know that. Now in the illustration, we're just using the atom 2 there. You'll have atom 1, atom 2, atom 3, atom 4 that deals with correction factors, adjustment factors, sizing the load, termination values, and all that. So engineers have always said that's the golden rule. It used to be in the ASHRAE Fundamental Handbook only, but now it's in the NEC and 310.14A3 atoms 1 through 4. And then if we looked at 250.24C1, then again, see, we're dealing with grounding and bonding and the grounded conductor and the neutral conductor and the effective ground fault path. And then, of course, the summary table 250.102C1, and again, we'll use 4-aught conductors and be consistent with that size. If we had 4-aught from the transformer in the illustration through the meter, terminating to a main, 225 amp, then that grounded neutral conductor you see there would have to be number 2, based upon the 4-aught conductors, and the number 2 selected from table 250.102C1. But then you'd have to size it by 220.61 for neutral load. And we know that we're told to do that in Chapter 7 of 70B, and to have an effective ground fault path, 250.4A5 tells us the same thing. So we know that's the rules. Now, when we drop down the National Electrical Safety Code says you got to ground at the transformers 92.B.1. That complies with 250.24A2 of the NEC. Now again, 220.61A says you carry the unbalanced. 250.24C1 and C2 is dealing with the transformer grounding and the service equipment starting it. 300.15E deals with how we'd use the neutral in the system. Then examples of what I'm telling you, you can find in the Annex D in the back of the NEC, starting with Annex D3A to the Annex D as in dog. And then again, you have to size the effective ground fault path by table 250.102C1. Now, this covers the most important things, but notice supply side grounding is the arrows pointing to the line side of that meter and to the load side of the meter down to the protected device. The supply side is 250.142A1. Now on the load side, you'll see the circuit breaker and the panel board with the equipment ground and branch circuits going out, and then load side grounding is discussed in 250.142B. But the equipment ground is sized based upon the breaker. You'd say, well, I have a 30 amp breaker. Then table 250.122, with your experience, you know this automatically, it'd be a number 10. Remember now, small conductors in 240.4D as in dog is number 10 down to number 18. Anything over number 6, like number 4 and larger, is considered large conductors and sets the pace and the fundamental requirements for sizing other boxes and things that deal with such size conductors. And you notice and remember that in Stallcup's Volume 1, Designing Electrical Systems, Chapters 1 through 13, we discuss all that. But it's just a reminder to you to always remember what is small conductors and what are considered large conductors.